G'day Year 10. Obviously, as we've been working way through this topic, lessons 1 through 5 have been on Surds, which is newer stuff, and there's some complicated stuff we've had to do in there. But we get a lesson here where we should feel fairly comfortable with this material. We've probably seen most of it before. In fact, in this lesson, you should have seen all of it before. So today is on the first 4 index laws. So there they are, all there. So we've got anytime we multiply two numbers with the same base but different indices, we add the indices. That's that first one there. And then the second index law is kind of the opposite, and it kind of just makes sense. If we're dividing two numbers with the same base with different indices, we take away the indices. And then the power to the power rule, which you would have all seen before, which is that if we've got something to some power raised to another power, then we multiply the powers. Okay. And finally, that anything to the power of 0 aside from 0 itself equals 1. So there's some rather simple little exercises here to go through just to jog your memory of what we used to do with these, but I know you guys have been able to do this with when it's popped up in other topics along the way. So this one, we've got the same base, so we can add the indices. So that's y to the 7 plus 3, so it's going to be y to the 10. Okay. Now, when we've got lots of numbers and lots of letters, the general best way to do things is to deal with the numbers first. So 7 times 2 is negative 14. X squared times x to the power of 3. We got same base, we add the indices. 2 plus 3 is 5, so we end up with x to the power of 5. And remember that y without an index is just y to the power of 1. So y to the power of 1 times y to the power of 5. We add 1 plus 5, and we're going to get 6. Okay, so if for C we've got the second index law being applied, so P5 divided by P2, remember, same base, we get to subtract the indices. So that's going to be P to the 5 minus 2, which is going to be P cubed. And then same again when we've got a few different letters and numbers going on, just deal with them each one in turn. So 8 take away 2 is going to be our powers for x. So x to the power of 8 take away x to the power of 2. Sorry, x to the power of 8 divided by x to the power of 2 is just going to give us x to the power of 6. Y to the power of 5 divided by y. Remember, y on its own is just y to the power of 1. So it's going to be 5 minus 1, so that's going to be 4. And likewise with the z here, we've got z to the power of 3 divided by z to the power of 1. So 3 minus 1 is 2. Okay, and we've got another one here with numbers as well. Remember, just deal with your numbers first. So 5 divided by 10, that's going to be 1 divided by 2 essentially. We factorise there, and 5 comes out of, it basically becomes 5 over 10, but 5 goes into 5 once and into 10 twice. And then we end up with x cubed take away, x cubed divided by x, which means we go x to the power of 3 take away 1, so that'll be x squared. And y to the power of 5 divided by y to the power of 3, that's 5 minus 3, and that's going to leave us with 2. The other way you could write that is just as a fraction with x squared, y squared on 2, which I think is probably the better way to write it. I was trying to break it up and do numbers and letters first, but generally with these things I tend to not use the divided by sign much. I tend to just create a fraction first up, and then you can sort of cancel things out. So our first example of the power to the power rule, here we've got y to the power of 3, then raised to a further power of 5. So this is going to be y to the power of 3 times 5. So that'll be y to the power of 15. Now, importantly, the position of the brackets is really key when we have the power of the power rule. So this power applies to y like we would expect it to, but it also applies to that 3. So we've got to square both of those. So we're going to end up with 3 squared is 9, and y to the power of 4 to the power of 2 is going to be y to the power of 4 times 2, which is 8. And for our next example here, I guess it's up to you how you want to go about things here. I think we'll get rid of that outside power first. So everything in those brackets gets raised to that power of 3. So 2 cubed is 8. Obviously, so that's applying to there and there, but it's also applying to there, there, and there. if that makes sense. I'll draw that a little bit better so you can still see the 3, I think. So we go to there, and to there, and then to there, there, and there. Okay, so x to the power of 3 raised to the power of 3, that's going to be x to the power of 3 times 3, so that's x to the power of 9. 3 cubed, so that's 3 times 3 times 3. Well, 3 times 3 is 9, 9 lots of 3 is 27. X to the power of 3 raised to another power of 3, we're going to end up with x to the power of 9. And y to the power of 2 raised to a power of 3, we're going to end up with y to the 2 times 3, which is 6. And now we can also look at this and go, well, hang on a second, both of these, there's no adding and subtracting going on, it's all multiplication and division, so I can probably cancel x to the power of 9 out of both of those. And I'm going to end up with 8 on 27y to the power of 6. Next we've got this power of 0 rule. Now this particular power, there's no brackets here, so this power only relates to the letter in front of it. So basically what I've got there, x to the power of 0 is going to be 1. So I've actually got 3 times by 1. Remember there's a little missing multiplication sign in between the 3 and the x. So the answer to that one is just 3. And just to illustrate the difference here, obviously in this particular case, for x to the power of 0, the x to the power of 0 is 1. So 4 times 1 is 4. Plus, now this time, this power of 0 is applied not only to the x, but it's also applied to the 3. So 3 to the power of 0 is 1. X to the power of 0 is 1. 1 times 1 is 1. So that's all that one is. So there's a big difference there between this little fellow on the left and this little fellow on the right, in that the power applies in the first instance just to the pronumeral, and in the second instance to the whole expression, to the whole term, sorry. So 4 plus 1 is 5, and that's the end of that one. So have a good go at those questions that are listed there in the textbook. I'll just have a quick squiz through them with you, but we should feel relatively comfortable. This is going back to very much Year 8 work as far as getting used to how it looks in expanded form. But as we get into, once we get into these working mathematically areas, and I think you should look for this little icon here when you're doing your maths. Now, ideally, the textbook is nice and it's sort of green is sort of the stuff that we're not doing but helps you build that knowledge. The blue stuff is kind of just using the knowledge that we've obtained in a very clear and concise way. And then if you're up to it, then we get into the purple section down the bottom, which actually asks you to asks you to reapply what you know to sort of problem solve. So the bare minimum I would like you guys doing is getting a good lot of questions done in this blue area, because that at least is getting the base skills down. But everyone should be striving to get at least some work done in these other 2 sections down the bottom. Just to see that you can actually take what you know and reapply it in a different set of circumstances. So that's all there is for this lesson. This should be Friday's lesson, so have a great weekend, and I'll see you on a Zoom session soon.